All right, ladies and gentlemen, welcome to example 3. No corrections that I can think of at this time. So we're just gonna move forward. All right, so I'm defining the probability of A is going to be using the idea that we spin a 5. I'm gonna say the probability of B is that we have a number greater than 3. And both of these are going to be 2 different spins. So the idea is, did we spin a 5 on the first one? And did we spin greater than a 3 on the second? And we need to remember that the probability of both A and B is the same thing as probability of A times the probability if it's an probability of B if it's an independent event. And by spinning a spinner, nothing is taken out. One spin does not directly change or affect the other one. Does it change where you start? Sure. Does it have to? No, you could always say we start at the upper position and then we spin. But it doesn't, like if we spin a 3, that 3 is still able to be spun the next time. So that makes it independent. Now what we're looking at here is the probability of spinning a 5. Well, there's only one 5 on the entire spinner. And there's 8 numbers. So my probability is 1 over 8. Then I'm looking at the probability of spinning a number greater than 3. Well, greater than 3 is 4, 5, 6, 7, 8. So that's 1, 2, 3, 4, 5 numbers. So I have 5 numbers that are greater than 3 here, and there are 8 total. So what I need to be able to recognize is knowing this is an independent event. I'm not checking it. I know that it is. I can take 1 over 8 times 5 over 8, and I'm going to end up with 5 over 64. So 5 over 64 ends up being about, now this isn't exactly, it's about, it's rounded, 0.078 or 7.8%. And that's my probability in all 3 forms, fraction, decimal, and percent.